In this lesson, you will learn how to configure FortiGate to act as a web proxy. In this lesson, you will explore the following topics: web proxy concepts, web proxy configuration, web proxy authentication and authorization. After completing this section, you should be able to describe how a web proxy works, use a proxy automatic configuration, PAC file, and web proxy auto discovery protocol, WPAD, to configure explicit proxy settings in web browsers. By demonstrating competence in web proxy concepts, you will be able to understand the fundamentals of web proxy operation. A web proxy receives or intercepts requests from a client to a server. If allowed, and if no cache is available, the web proxy forwards the client's request to the web server. Two TCP connections are created, one from the client to the web proxy and one from the web proxy to the server. A transparent web proxy does not require any configuration changes to the client's configuration. Clients continue to use the web, just like they would without a web proxy. Clients send requests to the web server's IP address and port number. The web proxy intercepts the client's requests transparently, that is, at the IP layer. The destination address doesn't change. How is an explicit web proxy different from a transparent web proxy? When you use explicit web proxy, you must configure clients to send the requests to the web proxy IP address and port number, not the website servers. Usually, you will enable the proxy to cache responses from web servers. A web cache stores responses from web servers. So when a client repeats a request, FortiGate can quickly send the cached content, response, instead of forwarding the request and waiting for the response. This reduces WAN bandwidth usage, server load, and delay. Web cache is supported in both transparent and explicit web proxy modes. Web proxies provide an extra layer of security. They can block any traffic in the standard HTTP and HTTPS ports that is not web traffic. Explicit web proxies offer another security benefit. Administrators do not need to allow direct internet access to clients. Only the explicit web proxy requires direct internet access. Administrators can enforce clients to send traffic to the web proxy first if they require internet access. The FortiGate web proxy solution offers two additional benefits. One is that administrators can use the content of the HTTP fields as matching criteria in the firewall policies. The FortiGate web proxy solution also provides an extra benefit not available if you are not doing web proxy: support for Kerberos authentication. Kerberos authentication provides a mechanism for doing Fortinet single sign-on, FSSO, without installing any agent across the Windows AD domains. How do you configure users' web browsers to use an explicit web proxy? One method is to set up the proxy IP address and port manually, using browser settings. In large networks, you can use an Active Directory login script or roaming profile, rather than configure each computer individually. Alternatively, you can configure browsers to use explicit proxies by installing a PAC file or using WPAD. When you set up an explicit web proxy by configuring the web browser settings, you must provide the proxy's FQDN or IP address and TCP port number. You can specify only one proxy address at a time. If you want to exempt specific destination IP addresses, subnets, and FQDNs from using the proxy, you can add them to a list. For those destinations, the browser will send the requests directly to the web servers. Another configuration method uses a standard explicit auto-configuration file called a PAC file. A PAC file contains instructions that tell the browser when to use a proxy and which proxy to use, depending on the destination. This configuration method supports the use of multiple web proxy servers. To deploy the PAC file, first you must install it on an HTTP server that the clients can reach. Your FortiGate can act as the HTTP server for the PAC file. Then, you must configure all browsers with the PAC file's URL. What does a PAC file contain? A PAC file is a JavaScript. It determines whether the request will use a proxy and what the addresses for the proxies are. In this example, the PAC file allows any connection to example.com to bypass the proxies. Connections to servers in the 10.0.0.0/24 subnet use the proxy named fastproxy.example.com. All other requests are made through the proxy named proxy.example.com. Browsers can use WPAD to determine the URL where the PAC file is located. WPAD can use two discovery methods, DNS-based and DHCP-based. When using the DHCP method, the browser sends a DHCP inform request to the DHCP server. The DHCP server replies with the PAC file's URL. When the DNS method is used, the browser first queries the DNS server to resolve the FQDN wpad.local-domain. The DNS server replies with the IP address where the PAC file is located. The browser downloads the PAC file from the URL http://pac-server-ip:80/wpad.dat. Most browsers try the DHCP server method first. If it fails, they try the DNS server method. Good job! You now understand web proxy concepts. Next, you'll learn about web proxy configuration. After completing this section, you should be able to configure FortiGate to act as a web proxy, reduce WAN bandwidth usage and improve responsiveness using web cache, apply security policies to web proxy traffic based on HTTP headers. By demonstrating competence in these topics, you will be able to configure a FortiGate as a web proxy. The steps for configuring web proxy differ according to the type of proxy, explicit or transparent, you are configuring. To configure explicit web proxy, you must 1. Enable explicit web proxy in the VDOM, indicating the interfaces that the web proxy clients will be connecting to. 2. Create proxy policies to authorize and inspect the web traffic. 3. Configure the browsers to send the web traffic to the web proxy. To configure transparent web proxy, you must 1. Create regular firewall policies to match the traffic, applying a proxy profile with the HTTP policy redirect setting enabled. 2. Create proxy policies to authorize and inspect the web traffic. Keep in mind that web proxy, explicit and transparent, is available only in VDOMs configured for proxy-based inspection. Once explicit proxy settings are visible in the GUI, you can enable and configure them. You must add the interface or interfaces that will be listening to explicit web proxy connections. Additionally, you can change the TCP port where the proxy is listening, edit and upload the PAC file, and choose the default action that FortiGate takes for traffic that doesn't match any proxy policy. The next step is to create explicit proxy policies to specify which traffic and users are allowed to use the proxy. Policies for explicit proxy are configured in a different configuration section from regular firewall policies. Web proxy traffic that does not match any policy is accepted or denied depending on the configuration setting default firewall policy action, shown on the previous slide. In FortiOS version 6.0, you must select the service for the proxy policy. To configure transparent web proxy, the web traffic must first match a firewall policy using a proxy option profile with the setting HTTP policy redirect enabled. This setting instructs FortiOS to redirect the traffic to the transparent web proxy. Regular firewall policies match traffic based on Layer 3 and Layer 4 information only. The web proxy offers more flexible and gradual policy matching based not only on information from those two OSI layers, but also on Layer 7 information, HTTP headers. The setting HTTP policy redirect affects only web, HTTP and HTTPS traffic. Other protocols' traffic is not redirected to the web proxy and is authorized and inspected based on the regular firewall policy configuration. Similar to explicit web proxy, the next step is to create proxy policies to specify when the transparent proxy must accept and inspect the traffic. Web cache is available both in explicit and transparent web proxy. It can be enabled or disabled per proxy policy through the CLI. Similar to creating firewall policies, when creating proxy policies, you use firewall address objects to specify the source and destination. There is one category of address objects that are used only for proxy policies: proxy addresses. Proxy addresses offer more granularity when matching HTTP traffic. They can match HTTP traffic based on the content of any HTTP field. For example, the HTTP headers include a field named host, which usually contain the FQDN of the web server. With proxy addresses, you can create policies that match the traffic based on this destination FQDN, regardless of the destination IP address. Another example is matching by URL pattern. Proxy addresses can match traffic to URLs that match a regex expression, regardless of the destination IP address. There are two groups of proxy address types. One group is for address types that are used as destinations in proxy policies. They can match URL patterns, URL categories, and HTTP host names. The other group is for address types that are used as a source in proxy policies. They can match HTTP methods, user agents, and other HTTP header fields. In the example shown in this slide, the administrator created a transparent proxy policy to block any attempt from the student_addresses subnet to upload files to the Fortinet website. The administrator created two proxy addresses for this purpose. The post_from_students address matches any HTTP post request coming from the student_addresses subnet. The Fortinet address matches any web connection to a hostname that contains the text string fortinet.com. Good job! You now understand web proxy configuration. Next, you'll learn about web proxy authentication and authorization. After completing this section, you should be able to configure FortiGate to authenticate, authorize, and monitor web proxy users. FortiOS 5.6 improves web proxy by separating user authentication from user authorization. User authentication is enforced by using authentication schemes and rules, while user authorization is enforced in the proxy policies. Authentication schemes define sets of authentication methods, form, NTLM, digest, and so on, and user databases, LDAP, local, radius, FSSO, and so on. Authentication rules are used to specify the schemes, the authentication methods and databases, to use depending on the user IP address and protocol. Up to 2 authentication schemes can be configured in each rule, one for active authentication and one for passive authentication. An authentication scheme specifies a method and a database to be used in one or more authentication rules. The available methods are basic, digest, NTLM, form, FSSO, and RSSO. If the method is configured as negotiate, the FortiGate negotiates the method with the web client. The available databases are local, LDAP, radius, FSSO, RSSO, and TACAX+. Not all the databases are available for all the methods. For example, you cannot select the local database if the method has been set to FSSO. Web Proxy supports two-factor authentication, which can be enabled in the authentication schemes. An authentication rule defines which scheme is used for active authentication and which scheme is used for passive SSO authentication. Authentication rules are matched from top to bottom, as in the case of firewall policies. The web proxy uses the source IP address and protocol to match the traffic and knows which scheme to use. The protocols between the FortiGate and the browser supported for authentication are HTTP, FTP, and SOCKS 5. The rules also define if the authentication will be based on IP address or based on session. The differences between both are described in this lesson. What happens to traffic that requires authorization but does not match any authentication rule? The active and passive SSO schemes to use for those cases is defined under Config, Authentication, Setting. Web proxy authentication can be based on either source IP address or HTTP session. With IP-based authentication, all traffic sessions from the same source IP address are treated as a single user. With session-based authentication, each session can be treated as coming from different users. How should you decide which to use? IP-based authentication requires less RAM to remember the authenticated sessions. However, it should only be used when each user has a different IP address, and there is no NAT device between the user and the FortiGate. If you have multiple users sharing the same IP address, such as in the case of users behind NAT, use HTTP session-based authentication instead. In this mode, each browser inserts an HTTP cookie in its requests. The cookie identifies the user. This method requires slightly more RAM because FortiGate must remember all session cookies. What does the traffic flow look like when a user authenticates with the web proxy using HTTP session-based authentication? If a user connects and the request doesn't have any associated authentication session, FortiGate replies to the browser, requesting login credentials. The browser prompts the user to authenticate and remembers the authenticated state by storing a cookie. If the same user makes more requests later, the browser automatically sends the same cookie again. FortiGate identifies the user by this session cookie. The user does not need to authenticate for every request, only the first time. Web proxy separates user authentication from user authorization. User authentication is enforced using schemes and rules. User authorization is enforced in the source field of the proxy policies by indicating which users or user groups can access which resources in the network. Once the web proxy is working, you can monitor which users are connected to it. You can do this from the GUI or from the CLI by using the command diagnose wad user list. Congratulations! You have completed the lesson. Now, you will review the objectives that you covered in this lesson. This lesson covered the following objectives. Describe how a web proxy works. Use a PAC file and WPAD to configure explicit proxy settings in web browsers. Configure FortiGate to act as a web proxy. Reduce WAN bandwidth usage and improve responsiveness using web cache. Apply security policies to web proxy traffic based on HTTP headers. Authenticate, authorize, and monitor web proxy users.